Hi everyone, today we're going to look at how we can use elimination to solve linear systems. Let's begin by looking at three pairs of equations and how we might add or subtract those equations to eliminate one of the variables. In the first example, if we add 2x plus 8x, we'll get 10x. And if we add 4y plus 6y, we'll get 10y. On the other side of the equal sign, 7 plus 10 will give us 17. We've added the equations, but it hasn't really helped us very much because we haven't eliminated one of the variables. Let's look at a second example. If we add 3x and 2x together, we'll get 5x. If we add positive 4y and negative 4y, we'll get 0y. This will have the effect of eliminating the y variable from our equation. We'll continue by adding the 12 and the 3 to get 15. This leaves us with 5x equals 15. We have successfully eliminated the y variable from this pair of equations. This would help us to be able to move on to find the y value of the point of intersection. In our third example, we can't add in order to eliminate a variable. We'll have to subtract. We'll do 4x, take away 4x to get 0x, and then we'll do 7y, take away 3y to get 4y. On the other side of the equal sign, we'll do 16 subtract negative 8, or 16 plus 8, which will give us 24. This will leave us with 4y equals 24. We have, in effect, eliminated the x value in this case. This would help us to be able to find the x value of the point of intersection once we determine the exact value of y where the two lines cross. Now let's look at a fourth pair of lines, and this time we'll actually find the point of intersection. So we'll begin by looking at the coefficients of the x's and of the y's. If you notice that the y values are both -1, because it's the same coefficient, we can easily eliminate the y variable. So what we'll do is we'll do x subtract 2x to get -x. And then we will do -y subtract -y, which is the same as -y plus y, or 0y. And finally, on the other side, we'll do -5 subtract -7, which is the same as -5 plus 7, and we will get +2. From here, we can solve. In front of our x, there's a negative sign. This is like a -1, so we'll need to divide both sides by -1. This will leave us with x equals -2. This is the x-coordinate of where our lines meet. We'll need to take this value and use it to find the y value of the point of intersection. We can pick between the two equations. I'll pick the second equation. So we'll take 2x minus y equals -7, and we'll substitute our x value of -2. 2 times -2 will give us -4. We'll leave our minus y for now and write equals -7. Now we can move the -4 to the other side of the equal sign and change it positive as it moves there. This will leave us with -y equals -7 plus 4. -7 plus 4 will give us -3. Now, in order to get rid of that negative sign from out in front of our y, we'll need to divide both sides by -1. This will give us y equals 3. So we can conclude that our point of intersection will be -2, or our x value, comma 3, or our y value. This is where the two lines will meet each other. In this example, we can once again see that there's a coefficient that is the same for one of the variables. Both the x terms have a 2 in front of them. So what we'll do is subtract 2x minus 2x, which will give us 0x, and then 3y subtract y, which will give us 2y, and then 12 subtract 8, which will give us 4. This will leave us with 2y equals 4, and we can divide both sides by 2 to get the y by itself. This means we'll have y equals 2. So our y-coordinate for our point of intersection is 2. We can use this and one of our equations, let's pick equation 2, to find the x-coordinate. So 2x plus y equals 8, and we'll substitute y equals 2. we'll have 2x plus 2 equals 8. Let's move that 2 across the equal sign where it will become negative, and that will leave us with 2x equals 8 minus 2, or 6. In order to get x alone, we'll need to divide both sides by 2. This will leave us with x equals 3. So the x-coordinate of our point of intersection is 3, and the y is 2. So our point of intersection will be 3, 2. Again, this is the point where the two lines meet, or the solution to our linear system. This last example is a little bit easier. In this case, you can see that there's a negative 2y and a positive 2y. So we'll be able to add these equations to eliminate one of the variables. If we add the 2x plus the 4x, we'll get 6x. When we add negative 2y plus 2y, we'll get 0y. And 10 plus 14 will give us 24. This will leave us with 6x equals 24. We'll divide both sides by 6 to get x by itself, and this will leave us with x equals 4. We'll take this x equals 4 and use it in, let's say, equation 1 this time. So we'll take 2x minus 2y equals 10, and we'll substitute x equals 4. This means we'll have 2 times 4, or 8, minus 2y equals 10. We'll move that 8 to the other side of the equal sign, remembering to switch its sign as it crosses over, and this will leave us with negative 2y equals 10, take away 8. So negative 2y equals 2, and we'll divide both sides by the negative 2, because that's what's in front of the y, and this will leave us with y equals negative 1. So our point of intersection for these two lines will be 4, negative 1. And that's how we use elimination to solve a linear system. Sometimes we'll add. If the coefficients of one of the variables are different, adding will be allowed. And if the coefficients are the same, we'll have to subtract. And when we do subtract, we'll need to be careful that we subtract each term correctly.